tutorial starts with a song, but it's only a few seconds long. Let's get started with animation. A while ago I did a tutorial about a cityscape. I downloaded it for free, and it's still free, from Kitbash 3D, which is a company which creates, well, very sophisticated, very detailed and very well shaded scenes. And I had the problem, and that I complained about that the Maya shaders, there's lots of Blinn shaders, typical Maya rendering engine shaders, are not Arnold compatible. So the scene, as complex as it is, does not really work with Arnold. Now, in the meantime, I complained about this to the company, and the company answered, we will put a stress on acting in that direction to offer more Arnold shaders with the new Kitbash 3D kits. But I got a message in the comment in that tutorial just a few weeks ago by Frank Parisis. I don't know him, but I really appreciate this. He said, well, you puzzle me because in Maya 2021 you have in the Arnold menu convert shaders to Arnold. Well, it's very cool, and it respects connections. Yeah, this is a brilliant idea. I have actually overlooked that convert shaders to Arnold menu entry, and now I'm going to show you how to use it. The command sits here under Arnold and shaders and convert shaders to Arnold. We cannot convert anything to Arnold currently because we don't have a shader in the scene, but we can easily create a torus like this. Press the key 6 in order to see it shaded. It stays great as it is. It's a Lambert shader, and we create a new material for it, a Maya Blinn shader. Now it looks a little bit more glossy, and we go to the Blinn here in the attribute editor and change the color. We map it with a ramp. This is all within the Maya shading family. Now we don't have to select anything. We just go to Arnold and shaders and convert shaders to Arnold, and we have the option to convert all shaders or the selected. Doesn't really matter. We convert all shaders to Arnold. Now we have a shader with a slight specular weight, 0.7. That's probably the interpretation of the Blinn shader, which the Arnold conversion algorithm thinks of. And we have the proper ramp shader here as well. So when we introduce a light, like a skydome light, we can render this in Arnold, and it's perfectly all right. Slightly glossy, and by the way, these edges here, I have a tutorial about tessellation. Just check it out if you want to get rid of these, but this doesn't matter in the context of this scene. Now I open a scene from the Kitbash 3D people, and the original is called Kitbash 3D NeoCities Native Maya. It's a Maya ASCII file. That means you can actually read it like a text, and I open it. It takes a while to open because it's quite complex. It's 0.5 GB in size. I think currently it's the only free kit available at Kitbash 3D, but this is only for demonstration reasons anyway. I always get this error message here. I don't know what it's about, and we don't care about it anyway. Now, when we render this, we can render this in Maya, no problem. Maya puts in a default light, but we can also create, say, a parallel light under lights, and it's called directional light. And if we scale it up, it looks like this, and we can just rotate it like this and maybe turn it there. And when we get closer, we have a problem because the scene is so big. I'll press the key F, I get a little bit closer, and now I can rotate around that building block. In the real life, if you use this kit, you would typically rearrange things, move this building somewhere else, scale it down maybe, or just use this set of smaller buildings here. Now let's have a look at the rendering. I render it not in Arnold, I render it with IPR, and you see here it's been rendered by the Maya software. I have to accelerate this because it takes quite a while to render in the Maya software. The rendering looks like a black and white image. We have only very few colors, and I wonder why that is. It probably has to do with the render engine of Maya. Actually, I need to fast forward it because it takes 5 minutes to render the scene using the IPR Maya algorithm for rendering. The Maya software algorithm is totally outdated, so you better don't use it, and we need to rely on Arnold and maybe RenderMan and other render software, but not on the Maya software. Now it's finished, and we see basically black and white, a little bit of green here, and I wonder why that is, and that's why I close this window and I go a little bit closer to this part here, this roof, and here you see all the details. And in the viewport, without rendering, the viewport shows us a very nice texture here with bump maps. And this is due to the bump map of the Maya Blinn shader. In order to see the Blinn shader, when you select this object, you select all the other objects too, because they all reside within the same UV texture space. But when I right mouse click here and select a face, for example this one, I can actually see the shader by right mouse click and material attributes, and this is the shader. I have the color, which is mapped with something which has to do with wood, and the bump mapping has something wood, dark gray, tower. This is the tower here. This is the bump mapping. The Arnold shader does not have this entry. It's under geometry in the Arnold's shading world, and I wonder if we can convert this into Arnold properly, the bump map. And you will see what comes out of it. But let's render this again. Now it goes faster, probably because the scene is basically cached. I wonder why there's barely any color in there. Let's keep this image in mind, in memory, and convert the whole scene, right mouse click and object selection, convert the whole shading world into Arnold shaders. In order to show you what is happening now, I open the Hypershade window. You see all the Maya shaders here, and they all have the specular color mapped, the eccentricity mapped, the specular roll-off mapped, lots and lots of shaders, and they're all here. Now when I go to Arnold and I choose Convert Shaders to Arnold and I select all of them, I get a very fast conversion, and now I have all Arnold shaders here, and the other ones are gone. And if they're not gone and hidden somewhere else, which I don't suspect, I can always go to File and optimize the scene size. Optimize current scene size. This action cannot be undone. That's just fine. And now we're basically done. We have Arnold shaders. This scene, the viewport, changes quite a bit, and we still have only one light, which is the parallel Maya directional light here. And now we can render it in Arnold and see what's coming out. Arnold needs to reinterpret the scene, and as you can see, we have barely any colors, but something brownish is turning up here. So we need to increase the intensity of the directional light, or use another kind of light. I usually raise the exposure here in the Arnold section, for example, to 4. And you see that we have quite interesting structures here, but the texture is slightly glossy. It doesn't look really rough. Let's inspect this again. I select the face, one of these faces, just this one for example. Right mouse click, material attributes, and I have the base weight. Well, this is the color, and this is the color mapping just like in the Blinn shader of the Maya software. Now it's an AI standard surface shader, and I have a specular weight of, well, it's mapped as well with specular color. That's why it's slightly glossy, I thought, but actually transmission is empty, subsurface is empty, but coating is not empty. It's set for all the shaders which are being converted, it's set to 0.5. And when we reduce this, the shininess goes away and we have bumpy wooden texture shading. I'll show you a few renderings. Oh, and this turns yellow here, very nice as well. You would have to do all the coating work if you're getting near with your camera to it. But now you see already that with Arnold this looks much more nice. And let us delete the directional light and introduce a skydome light instead. And you can always map the skydome light with a file texture, which is an HDRI image typically. This is a 360-degree photo I took with my drone. It doesn't matter what it really is, but now you see the sky turning up and turning the scene, giving it a blue tint, basically. And now things are turning out very nicely. By the way, the windows are transparent, semi-transparent, so you can put people inside of that building. And actually, if you want to light the windows here when it gets dark, for example, you need to create new geometry within these boxes, because this whole building is just one box. So when you put one light in there, the light shines through all the windows. You will see this in a rendering which I'll demonstrate just at the end of this tutorial. Where is the bump map? Well, we don't have the bump map here. The bump map in the Arnold shader is down here under geometry. And do we see a mapping here? Yes, we do. Here is the bump map which we use for the concrete accent, wherever that is. So the bump map is actually there. It was converted properly from somewhere up here in the Blinn shader to down here. And the whole magic is through Arnold shaders, convert shaders to Arnold. And thanks to Frank Parisis for this nice hint.